Great. Yes, my name's Natalie. I'm with the University of Florida Shellfish Extension Program. And today I'm talking about water suitability parameters at our clam seed production facilities. We took hatchery and nursery source water samples once per year, and this was done by project personnel at all three different geographical locations. And we timed this to coincide with production schedules, periods of high rainfall, runoff, aerial spraying events for pesticides and herbicides. And we actually sent these off for analysis for a full suite of ions, heavy metals, IOCs, VOCs, specifically the herbicide glyphosate and pesticides. As I go through some of the values, it's important to acknowledge that there are no acceptable values or recommended ranges for these parameters established for shellfish aquaculture. So what we did was we're providing resource guides that utilize the information obtained from this 2-year project from all participating facilities. And these values can be used as a reference for when you're comparing your tank source water or your tank water values as well. In addition to these guides, we have troubleshooting procedures, comments, additional resources, and references. And year 1 and 2 reports are all going to be posted onto our website. Again, these are all identified by codes to preserve anonymity. So the first reference guide that we provide is the chemical composition of culture water. And this is done in comparison to salt water at 35 parts per thousand. We took water samples and we sent them off to Midwest laboratories, which analyzed 28 different parameters, which include your ions, your harmful metals, and your IOCs. This is a short guide. It just looks at year 1, year 2, the average, min, max of all the facilities that participated. Again, these are your reference values for when you're looking back at your reports. I want to note that in year 1 and year 2, the averages are very similar and they're comparable to that of saltwater. A follow-up guide was provided specifically looking at the 11 heavy metals that were analyzed. And this is done in reference to, again, saltwater at 35 parts per thousand and the FDA action level. Now, the action level is the quantity at which the FDA will take legal action in removing adulterated product from the market. So that does include shellfish. And in year 1 and year 2, all our values fell well below the action level. So that's good news. But should you have a problem or think you might be having a problem with any types of heavy metals, we provide troubleshooting procedures and comments, most of which are going to look at biological and mechanical filtration. However, if you're looking at specifically cadmium, chromium, copper, lead, and zinc, these methods might be insufficient at the removal, and you might want to look at a metal chelator known as EDTA. That might be a little bit more beneficial. And what EDTA is, it binds with your divalent cations, making them less toxic, specifically to the eggs and the larvae of your aquatic shellfish. Routinely, it's used in shrimp hatcheries at 3 to 10 milligrams per liter, and it's sometimes used in bivalve facilities. We've spoken to Scott Reichert at Auburn Shellfish Lab, and although they have not quantified the effects of using EDTA at their facility, they typically use 1 milligram per liter. So you might be asking yourself, should I be using EDTA at my facility? It does come in reagent grade and commercial grade known as Versine. The Versine is going to be a little bit more cost effective, but as always, we recommend running a little experiment. So set up some tanks, smaller tanks using live animals, put in your EDTA application rate, and then also set up your control tank where it's just the animals and no EDTA. Check what the survival and growth rates are and make sure they're comparable before you apply this to your whole facility. In addition to this, we looked at VOCs, which are high vapor pressure, low water solubility chemicals. Typically, you're going to find them in your paints, pharmaceuticals, and refrigerants. These are all man-made. We sent these samples off to Midwest laboratories to analyze over 80 VOCs. You should not have any VOCs in your source water. If you do, we have to play detective and determine how is it entering your source water and how can I stop this? So again, you should not have any of this. But we ran the reports. And in year one, 9 of the 10 facilities had less than the reporting limit for all 80 of these chemicals. The reporting limit is the smallest quantity at which they can identify that specific chemical using the APA analytical procedures. So in year one facility did record a value of 25 micrograms per liter of tetrahydrofuran. It's typically used to make plastics and be found in your PVC pipes. It's not expected to build up in the tissues of fish or other wildlife. In year two, 9 of the 10 facilities again did not report any of the 80 VOCs. They all fell below the reporting limits. One, however, did have a value of 51.4 for acetone, which is commonly used as a cleaning solvent. We use it really to clean surfaces, remove grime from PVC before plumbing. That same facility also had a value of 8.4 micrograms per liter of bromoform. It's a colorless liquid, has a similar smell to chloroform. It's used for disinfectant, solvents, for waxes, greases, and oils. So what do these 3 chemicals typically have in common? They're used for cleaning. They're used in PVC plumbing. So if you're doing this type of work at your facility, be mindful of how close you are in proximity to your source water and your tank water as well. You definitely don't want them entering your system. But again, this is just a one-time sample. We just go into the facility, take one sample for that year. So it might have just been that they were doing that work that day or within that week, and we didn't capture it again. In addition to this, we looked at herbicides. We worked with Georgia Water's Agricultural Lab and specifically looked at the herbicide glyphosate. And this was after discussion with UF-IFAS Center of Aquatic Invasive Plants. So they told us that DOTs typically use glyphosate when spraying. You can find it in agriculture, forestry, even at Lowe's when you're buying your own lawn care products. We ran this analysis for nurseries in both year 1 and year 2, and all that facilities had values less than the reporting limit of 10 parts per billion. So we did not find glyphosate at any of our facilities. In addition to this, in year 2, we ran pesticide analysis for our nurseries. We sent these samples off to Midwest Labs where they actually analyzed 20 different pesticides all at once. I do want to note that we contacted our local mosquito control departments, and at 2 of these facilities, Nalid was the active ingredient that was sprayed, which was captured in this analysis. And at both of those facilities, they had reporting limits less than 1 microgram per liter for that pesticide. I also want to note that the other facilities that were in our project had active spraying ingredients called permethrin. We contacted a number of facilities and analytical labs, and they are unable to run samples or water samples for this. So we couldn't detect permethrin. So if you're interested in continuing or even doing some of this sampling at your facility, there are many analytical labs to choose from. We specifically use Midwest Laboratories and Water Agricultural Labs. And again, it was a WT or irrigation suitability, IOCs, POCs, pesticides. We looked at the 20 pesticides, and then glyphosate for our herbicide. Later, I will go over our website where you can find all our resources, including the project results, the resource guides that we displayed, and then troubleshooting procedures. So with that, I'll take any questions. Yes.
I was just wondering, what's the cost per sample?
For what?
What is the general cost or cost range for per sample?
So for the water suitability test, 1 water sample, when you send that out, that's for your ions, your heavy metals, and your IOC, that's a $400 test. For your VOC samples, that's about a $200 test. For the, I believe it's glyphosate, was $185 test. And then the pesticides, I believe, was about $200. So it can be quite costly to test for these, which is why we were only able to do it once per year. And we specifically, again, scheduled them to coincide for like spraying events. So we would call up DOT. When are you expecting to spray? Can you call us when you're about to do it? So that we could time our sampling of our facilities that way. Yep.
I have 2 questions. One, mercury, lead, cadmium, we know are toxic in all amounts, and as measurable as you can get to it. With regard to copper and zinc, those are basically considered a essential micronutrient.
Yes, they can be positive.
Yeah, so therefore we have, when you look at all these five different metals, or
Mhm.
are we hurting the efficiency of the copper and zinc in shellfish by trying to eliminate all five?
So typically EDTA is not routinely used in our facilities. It's really if you're identifying a serious issue that you might want to start using that. But like you said, it can be beneficial. And in our troubleshooting procedures and comments, we actually link to different articles that tell you the benefits of having some of these in your system. But again, there's no recommended or acceptable level. So that's where we're providing that baseline data for what's going on in our facilities. And so if you start seeing shifts at your facility, you can utilize that information.
The second question is different. Orca, a local NGO down in Martin County, or St. Lucie County, found in their flesh samples of all the fish they sampled from about this point all the way down to the St. Lucie Inlet, glyphosate in all the fish samples, which surprised me.
Mhm.
Would glyphosate then, would that wipe out the seagrasses? I know that's not related, but it affects the whole environment.
No,
Glyphosate would not affect. the
no, and we
seagrasses.
do link to a couple of resources for glyphosate as well, but based off their application rate and the way we were sampling, if we didn't capture it in our water supply samples coming directly from the surface, my answer, I don't know.
If you're interested, actually, Dr. Austin Fox will be given a presentation about glyphosate and its effect on seagrasses at the Indian River Lagoon Council upcoming quarterly meetings.
That's great.
Those meetings unfortunately are not live streamed.
Okay,
But Dr. Austin Fox also gave that presentation at the Brevard Sorrel meeting, and that is online.
so we might be able to link to that on our resource. Thank you for those questions.